Okay, good morning everyone. Welcome to this my YouTube channel. My name is Godagem Baradu. I'm very happy that you're here today. And if you're new here on this my YouTube channel, please I would like you to subscribe to this channel, like the video, share it, so that other people will also benefit from it. Thank you very much. Now let's look at how to find the equation of the tangent and normal to the curve. Look at this example. We have x squared plus xy minus y square equals to 3 at point 3 comma 1. They say that we should find the equation of the tangent and normal to the curve of this function x square plus xy minus y square equals to 3 at point 3 comma 1. How are we going to find this function, the equation of the tangent and the normal? You need to understand that the equation of the tangent is different from the equation of the normal. So this is a two question. It comprises of what? Two question. So let's look at how to find each of them. Before we find the equation of the tangent and the normal, we need to do what? First differentiate this function. So first thing we are going to do is to first differentiate implicitly. When we talk about to differentiate implicitly is to differentiate them differently, because we have two terms here, they are not in the same terms. We have x and y. If the thing was in the same terms, like in the same term of x, we differentiate them like normal differentiation. But because of the things in the term of x and y, we differentiate them what? Separately. That's what we mean by differentiating implicitly. So let's look at how to differentiate it. We differentiate here x square with respect to y. We differentiate here x. Here we differentiate x with respect to y. We differentiate y with respect to x rather. Then plus, there is plus in between. Then we now differentiate x. We now differentiate what? X with respect to y. Then after that minus, this minus now we differentiate this y square, then equals to, we differentiate a constant. So we are differentiating them what? All this term now implicitly. We are differentiating them what? Separately. That means we differentiate this x square separate, we differentiate this one, this x with respect to y, then we add plus in between, come differentiate the x with respect to y. Then after that we differentiate this y square also, differentiate the constant. So let's look at how to differentiate it implicitly. Say firstly do what? We differentiate what? Implicitly. We differentiate this x square, which is this, we differentiate this x, we differentiate this y rather with respect to this x. That's why this x is at the front. Then we put plus. Now differentiate what? Now differentiate the y respect to x. After that we differentiate this y square, differentiate the constant 3. So when we differentiate this x square, this 2 now, power 2 will come down to the front, multiply the function, which is x. Then we subtract 1 from the square. This 2 now is being what? 1. And we know that this thing is raised with an invisible 1. That's why I have, when we differentiate x square become what? 2x plus, when we differentiate y, we have what? Dy dx. Dy dx, because 1 minus 1 is what? 1. So this 1 times this divide x, the same thing divide the x times this x here. That's why I have x divide the x. We put divide the x because we are differentiating with respect to y. But when we are differentiating only x, we did not put what? Divide the x. When we are differentiating it implicitly. Then here we differentiate this x. When we differentiate x, you have an invisible 1 here, so subtracted minus 1 will remain what? 1 minus 1 remains 0. And anything raised to the power of 0 is 1. So we have 1 times this y, it's same thing as y. Then minus, we differentiate this y square. When we differentiate y square, this 2, we multiply this function, this y square become 2y square. Then minus 1 from the power, which is 2 here. We are going to have 2y raised to the power of 1, but that one is invisible 1. That's why I have minus 2y. And we know that when we differentiate with respect to y, we're going to add it with what? Divide the x, because this is implicit differentiation. Then equals to, this is our constant. When we differentiate this constant, which is 3, what we are going to have here is what? 0. So take note of that. Now, let our divide x stay one side, then the other terms will go on the right hand side. Because these 2x did not have the y dx, we cross multiply it to this right hand side, it become minus 2x. Then this y plus y now did not have the y dx, so when you cross multiply to this right hand side, it become minus y minus 2x. That is it. We put all these things that did not have the y dx on our right hand side. The one that attached with the y dx, we put them on the left hand side. And what remains here now is this x dy dx minus 2y dy dx. Now we just factor this thing out, dy dx, factor dy dx out of these two functions. So what is remaining is that when you remove dy dx here, remain what? X minus, when you remove dy dx here, remain what? Minus 2y. So we just put them in bracket, multiply the dy dx, because if you still multiply this dy dx times this thing, we're going to have x dy dx multiply divide x with this minus 2y going to give us the same thing, minus 2 divided x. So we just factor it out like this, and it give us x minus 2y bracket close and the y all over the x equals to minus y minus 2x. So in this case, know that we want to make this divide the x the subject of the formula. So anything that attached to the subject of the formula will go down to divide. That's why this minus 2x minus 2y now come divide this thing that we have on our right hand side, which was minus y minus 2x. So our final answer become what? Divide the x equals to what? Minus y minus 2x all over x minus 2y. This is our final answer for divide the x, but this is not our final answer for the question. So now this divide the x, now we know that say at point 3, 1, so we are going to find the tangent and the normal of the curve. You know that in a point, the first thing we have here is simply what? X. The second one is y. So you know that now from our divide the x here, anywhere we see y, we know that our y is what? 1, and our x is what? 3. So anywhere we see y, we substitute what? 1. Anywhere we see x, we substitute what? 3. So from that place at point 3, 1, that is our x is what? 3, and our y is what? 1. So anywhere we see y, it put what? 1. So because of this y now become what? Minus, instead of minus y become what? Minus 1, because our y is what? 1. Minus 2 times this x now is what? 3. We substitute 3 in place of x all over. This our x here is what? 3. Minus 2 times this y now, you know that our y is what? 1. So minus times minus times 1 is become what? Minus 1. Then 2 times minus 2 times 3 become what? Minus 6 all over 3. This 3 here minus 2 times 1 is going to give us minus 2. So minus 6 minus 1 minus 6 is going to give us minus 7. And then 3 minus 2 is going to give us 1. So minus 7 all over 1 is going to give us what? Equals to minus 7. So we know that therefore our divide the x, which is our gradient, is equals to minus 7. So we are already getting the value of our gradient here. So for us to substitute it into the equation of the tangent and the normal to the curve to get the actual value. So the equation of the tangent is given by the formula. This is the formula for equation of the tangent. Bracket y minus y1 equals to dy over the x times x minus x1. So this is the equation of the tangent. Don't forget it. Y minus y1 equals to dy over the x times x minus x1. This is our equation of the tangent. Anywhere we see this dy over the x here, we substitute what? Minus 7. Because our dy over the x we find here after differentiating it implicitly is minus 7. So we just substitute the value of divide the x as minus 7 in our equation of the tangent and the normal of the curve. But this is the equation of the tangent to the curve, and it's given as y minus y1 equals to dy over the x times x minus x1. So now let's look at since dy over the x is minus 7, our x1, we know that our x1 is what? 3, and our y1 is what? 1, based on the point they gave us at point 3, 1. So now we substitute the value. You know that our y now, based on the equation of the tangent, is given as y minus y1 equals to dy over the x times x minus x1. And this is our y. Our y here, this is our y minus, this is supposed to be y1. So we know that our y1 is what? 1. We substitute the value of 1 and equals to, this is our dy over the x. And we know that our dy over the x is what? Minus 7, based on how we differentiated implicitly recently. Then bracket x minus x1. You know that our x1 is what? 3. So that is why you have y minus y1 equals to minus 7 times s minus 3. So this is y minus 1 equals to minus 7 times s, going to give us minus 7s, plus minus 7 times minus 3, going to give us plus 21, because minus times minus is plus. Now in this case, we make y plus y now become what? Plus 7s, because this, when minus 7s cross the equality sign to this left hand side, become what? Positive 7s equals to 21. When this minus 1 cross to this right hand side, it becomes plus 1. So y plus 7s equals to what? 22, because 21 plus 20, 21 plus 1 is 22. Therefore, the equation of the tangent to the curve become what? Y plus 7s equals to 22. This is how to find the equation of the tangent of the curve. Now let's look at how to find the equation of the normal to the curve, because the equation is in two forms. We should find the equation of the tangent and the equation of the normal. So for us to find the equation of the normal to the curve is given by the formula. We have the equation of the normal is given by the formula y minus y1 equals to minus 1 all over the y over the x times x minus x1. You know that this particular formula of equation of the normal, you have minus 1 before the all over the y over the x. But the tangent own, there is no minus 1. You just have the y over the x times x minus x1. So this one now, the equation of the normal to the curve is given as y minus y1 equals to minus 1 all over the y over the x times x minus x1. So in this case, y minus, you know that our y1 is what? 1 equals to, substitute 1 here in place of y1 here, equals to our dy over the x is minus 1 all over, you know that our we know that our dy, you know that our dy, our dy was what? Minus 7 rather. Our dy was minus 7, So minus 7 times x minus 3. So in this case, what we are going to do now is that we cross multiply this minus 7, multiply both the left hand side and the right hand side. So we are going to leave with here minus 7 times y minus 1 on our left hand side equals to minus 7 here. We multiply this place here, this on our right hand side. So minus 7 minus 7 going to cancel out. We are going to left with what? Minus 1 times x minus 3. So minus 7 times y is going to give us what? Minus y. Minus 7 times minus 1 is going to give us what? Plus 7 equals to minus 1 times x is going to give us minus x. Minus 1 times minus 3 is going to give us plus 3. So here now, you know that minus 7y become what? Minus 7y plus x, because when this minus x cross the equality side to the left hand side become plus x, then this is what? Positive 7 rather, positive 7 here. So when this positive 3 cross the right hand side to the left hand side become minus 3. So we have what? Minus 7y plus x. Then here we know that 7 minus 3 is what? Is 4. 7 minus 3 is what? 4. Is 4 equals to 0. So therefore the equation of the normal to the curve become what? Minus 7y plus x minus 4 rather, minus 4. So this is our final answer. This is how to find the equation of the tangent and the normal to a curve. If you have any question concerning this equation of the tangent and normal to a curve on this our tutorial today, you can drop it on the comment section. And please, if you are not subscribed, you can subscribe to this channel now so that we can learn together and get the best out of our study. God bless you. Share this video to your friend also, and check next on video we have in this channel. Thank you very much. God bless you.